Block of base 10 centimeter into 10 centimeter and height 15 centimeter is kept on an inclined plane. The coefficient of the friction is root 3. The inclination theta of this plane is slowly increased from 0. Then what will happen beyond certain angle? Now let us see the two possible conditions for a given body. Okay, let me say this is theta. Okay, let me say this angle is theta and this box is placed. Okay, now let us assume this block never tumbles, so it means that at what angle will it start slipping? Now it is very much clear that there is a single body, so mu will be equal to tan theta. Okay, so that mu over here is given as root 3 is equal to tan theta, so theta will be equal to 60 degree. Okay, at an angle of 60 degree the body will start sliding down. Okay, if it does not tumble, let us assume that it does not tumble, then at angle 60 degree the body will start sliding down. Till then it will be at rest at that point. Okay, now let us consider the second case when the body tumbles. Now what is the condition for tumbling? If I consider the body, there will be mg along this direction, okay, at the center of mass. So I can divide it into two parts. This will be equal to mg cos theta and this is equal to mg cos theta. Okay, so there will be a friction force which acts in the backward direction and this will be equal to mg sin theta. Now let us consider all these three forces. Now at which point will the body tumble? It will tumble along this point, that is the rightmost point. Okay, along the rightmost point it will tumble when the force crosses certain value. Okay, now if you consider the height over here, the base is given as 10 by 10. So basically if you take this distance, it will be equal to 5 centimeter, and if you take this height over here, it will be equal to, now the height is given as 15 centimeter. So the height of the center of mass will be equal to 7.5 centimeter. Okay, the height of the center of mass will be equal to 7.5 centimeter. Now let us see the torque due to this two. Let us see the torque due to these two forces. Okay, the friction force will not play any role because over here the friction force is in line with the point. Okay, if it is in line with the point, the perpendicular distance becomes 0. Now let us see the torque due to this point, that is the torque due to the mg cos theta. It will be equal to mg cos theta, the force is mg cos theta, into perpendicular distance is 5. Okay, that is, it keeps the body stationary, or it applies a torque in the anti-clockwise direction. Now let us see the torque in the clockwise direction. This is anti-clockwise direction, this is clockwise direction. It will be equal to mg sin theta into the perpendicular distance over here is equal to 7.5. That is, it provides the torque in the clockwise direction. When will the body tumble? It is very much clear that the body will tumble when the clockwise torque increases the anti-clockwise motion. Okay, so when the torque clockwise crosses the anti-clockwise motion, the body will tumble. So basically let us see, mg sin theta into 7.5 should be greater than or equal to mg cos theta into 5. Okay, then only the body will tumble. So mg will get cancelled out. So tan theta, okay, tan theta, if it exceeds a value of 5 divided by 7.5, which is equal to, if it exceeds the value of 2 by 3, if you see if I find out the theta over here, the theta will be, or the minimum value will be roughly equal to 2 by 3 will be equal to 0.66. okay, 0.66. so roughly it will be around 40 degree. Okay, roughly it will be around 40 degree. Okay, so beyond 40 degree or beyond 30 degree, it will come out to be beyond 30 degree. Okay, instead of 40 degree it will come out to be 30 degree, 0.66. if you find out tan 30, it will be equal to 1 by root 3, which is equal to 1 divided by 1.7. okay, so which comes out to be roughly equal to 30 degree. So it will be slightly smaller than the 30 degree. Now over here it means that if I increase the angle beyond 30 degree, the body will tumble, and if I increase the angle beyond 60 degree, the body will slide down. So clearly if I see over here, when I go on increasing the value, the first value that I encounter is the 30 degree, then I will encounter the 60 degree. It means that before I reach that 60 degree, the body will start tumbling. Okay, it means that the angle over here is not given. Okay, but the option number B, if you read the option number B, the block will remain at rest on the top of the plane up to a certain angle theta, and then it will topple or it will tumble along the plane.